Good day, ladies and gents. We are continuing Unit 1, Building Blocks, that unit. So this is the hot topics. This should be sitting in front of you while you do this for a number of reasons. There's a lot of good notation on here that you guys need to remember, such as right here. So a line AB, the notation has the two arrows at the top. There's infinite amount of points and there's 0 endpoints. Line segment AB. So notice there's no arrows. Once again, it has infinite amount of points along that line. And there's 2 endpoints. One right there, one right there. And ray AB. So it starts at A, it shoots through B, and it has an infinite amount of points on there. And once again, so there's infinite amount of points. And there's 1 endpoint. Okay, there are 3 undefined terms in geometry, and that's points, lines, and planes. And all of those do not have a, there's no width or length, or they're undefined. So this point, we could be talking about a dime, or we could be talking about a state. We can be talking about a country, like where's the location. A line, we could be talking about a string. We could be talking about a road. And then planes. Planes are, it could be the size of the paper. It could be the size of your desk. It could be the size of a land. It's a plane. So that's what plane is. So it's undefined. Like it goes on forever and ever in either direction. So those are the things that you should have learned last time. So you guys had a chance to try the practice. Just fake it until you make it and see if you can get the right answers. So this first one right here was talking about drawing things. So this part right here is about talking about drawing certain things. So let's do a couple of these problems. I'm just going to randomly pick some problems. So through any 2 points, there's exactly 1 line. So if I put a point here and I put a point here, okay, well, there's only 1 line that can go from one to the other, and that's this line. That's the only line that draws from one to the other. Okay, so I'm just going to move this a little bit. All right. Okay, 2 distinct lines can intersect only at 1 point. So if I draw a line like this, and I draw another line like this, and they crisscross. So as long as they intersect, where is the location? Well, right there. There's no other two things. So these right here, they only intersect at 1 point, and that's right there. So these are just a couple examples. Okay, this one. Okay, so you see the dotted line? So that's like your straw going through Mountain Dew. So that is like your straw going through the top there. So I'll zoom out a little bit here. Okay, so it looks just like this. So this is my plane. Here's the straw. So this right here, this would be my red straw. So to help us out, I'm just going to highlight this red so I can get an idea that this is my straw that's going through that plane, just like this. Okay, so that's just like this. So everything that's white is going to be the plane, and everything that's red is going to be the straw that's going straight through this. Okay, so R is on that, and then nothing, and N is also on that straw, and that shoots right through there. Okay, I'll zoom back in. All right, so let's talk about a couple things. So what is the intersection of CM and NR? All right, so let's see. Here's CM right here. That's that line. And RN, this line. So where do these 2 lines intersect? Where do those 2 lines intersect? So the red line and this black line, they intersect where? And 2 lines intersect. So basically take a step down, right? So there's planes, so there's points, and then there's lines, and there's planes, right? Okay, so when 2 lines intersect, take a step down, and it would meet at a point. So when 2 lines intersect, they intersect at a point, and where did those 2 intersect? That was at N, so point N. So we can just say, point N. So we can say N, or we could say point N, whichever one you prefer. So this would probably be the best one, or if they give me multiple choice, we just say N. Let's see. I'm just skipping around here. True or false? plane V can be named as ANR. Okay, so to make a plane, we talked about it only being a triangle, right? So as long as those 3 points make a triangle, then it would be a plane. Okay, so let's see. ANR. So if I connect those 3, yes, I can make a triangle out of those 3, so that would be true. That would be true. So ANR. So that would be true right there. Wait a minute. There's a problem. Here's the problem. Yes, they make a triangle. That's the plane, but they want to know is it all on the white? On the white, sorry. Already a typo right off the bat. So they all have to be on the white plane. So AN and then R is on the straw. So this is not on the plane. So A N and then R is up here on the red. So this did not. So we actually were off of this little thing right here. So that did not work out. So a good one would have been A and C. So R messed up. So A and C would have been good because they were all on the white. But because R is up in the air, and it's a good thing that I made that red, because the fact that it was red, it was like, wait a minute, something's wrong. So that right there was really false. So any triangle makes a plane. That is a plane, but they were specific to what makes plane V. What makes plane V? And so it had to be on this white thing right here. Okay, how many lines are shown in the drawing? So how many lines do you see? Just count them. And then put that number right there. Okay, so that should give you a nice idea there. Okay, I'm just skipping around, giving you some ideas. Okay, so let's see. GH and HG are the same ray. So let's see. So if I have, they want to know, is this always, sometimes, or never true? Is this sometimes, always, or never true? All right, so let's see. If I have 2 points, and one is G and the other one is H. So if we're given that right there, G and H. Okay, so is GH, so I start at G, I go through H, and I go forever and ever. Is that the same as H to G? So I start at H, I go through G. Is this the same ray? Nope. That is not the same. Those two are not the same. So that is, so the answer is that how much of that is true. So they do share points, but they're asking, are they the exact same ray? And that is never. So they want to know, is it the same ray? If they said, do they share points? We would say sometimes. So yeah, they share points. Do they share all the same points? Nope. Okay, let's see. So let's think. This one. If I have J, I, and L. J, I, and L. And I don't know where these points are. I'm just making up stuff. So are they opposite rays? Well, let's see. If J to I, it shoots through I, goes through L, boom. Are they, and then I start at J and I go through L. Okay, those are the same ray. That's the same ray. But can I make these opposite rays? Well, let's see. If it was I over here, J in the middle, and L over here. If I start at J and I go through I, and on the other one I start at J and I go through L, yes, those are opposite rays. They go in opposite directions, so that those are opposites. So I can show you a counter example, and I can show you an example. So I can show you something that works right here, and one that doesn't work. So that would be sometimes. So we have never over here, sometimes over here. So all you need is one counter example to make it sometimes. If you can't think of a single one, then it would be never. Okay. Okay, and then we're looking at this. So this is all on the plane. I'm just skipping around. How many lines appear in the figure? You can probably guess that one. Yes or no? Line YZ. So I'm on D right now. Line YZ. Okay, is line YZ containing point W? So is point W on that line? Yes, it is. Yes, it is. So hopefully this is giving you a nice idea here. Okay, circle another name for line A. So here's line A. That's the name. It's at the edge here. There's no point with it. It is in cursive. It's lowercase, so that's the name of the line. All right, so we want another name for this. So we could, is YZ, does YZ along this? YZ, nope, that does not work. YZ did not work. How about WD? W and D. That definitely doesn't work because D is not even a point. How about VX? Yep, that works. Y, WY. Nope, see, we want this line right here, so that doesn't work. And WX. Yep, that works. So we wanted something that was this line right here. We wanted this line right there, and we needed those points. All right, so hopefully that give you a nice idea of how to do this. So on the home learning, remember for the home learning, make sure that you're doing this on the forms because I made this multiple choice. It's much easier than doing it cold turkey, so hopefully that helps you guys out. And if you're having trouble figuring out what this is, maybe you can just use your binder and just put it down on the table. I'll show you an example. So just grab an example real quick. So I have my binder here. Whoop, wrong way. Okay, so I have my binder. So there's my binder, and then here are the corners. So this, I could say that this is B, this is A, this is C. If I just, and right here would be H, and this would be F. This is G. Over here is D. Down here is E. So that gives you a nice idea. So if you're getting stuck and you can't envision this as a 3D shape, just look at a binder, and that should help you guys out. All right, so that's 6. So that's page 6. Now let's get to the real stuff. All right, so what are we supposed to be learning today? I know that all that big review, and you're like, wait, that wasn't even the main point? Nope. Okay, so what you guys are supposed to be learning today is talking about midpoint and missing endpoint. So midpoints and endpoints, that's what we're talking about today. All right, so make sure that this is at the corner of your desk. This should definitely help you out. So we're going to be talking about these things right here. So, so this should really help you out because see how it's lines. Okay, so when we have R is the midpoint of this line, so we made this, and R is in the middle, so that means that these two sides are equal to each other. So left is equal to right. Okay, and then so that's the midpoint. So this side is equal to this side. Excellent. And then this right here, if it's not the midpoint, but it is still a line, and E is along this line, then it would just be this plus this equals the whole shebang. So you just, this plus this equals the whole shebang. You just add them together, set them equal to the whole shebang, and you would solve. So these two examples should be sitting next to you the whole time you're busting this out, and this should really help you out. And this is one of the main reasons why if you get this right, then I know you know how to really do Unit 0. So if you did not rock Unit 0, then this is you're gonna have a lot of trouble with this. But if you do rock this section, I can go back and fix your Unit 0 test grade. All right, let's do some examples, shall we? All right, so we're on page 7. So page 7, we're gonna take some notes. Okay, if equal, then the segments are congruent. This is written as congruent, the little equal sign with a squiggly above it. That's equal. All right, so check this out. What we're going to do is we're going to count the hops. So count the hops. Count the hops, not the dots. Be the bunny. So I want you to count from A to B. Count from A to B. Go ahead, do it now. Now, a lot of people might accidentally go 1, 2, 3, 4, 5. Is it 5? No, because you count your hops. See, I'm at A. I didn't go anywhere. A lot of people are like, 1, but I didn't move. So I didn't go the 1 mile. I stayed exactly where I was. So you want to count the hops. 1 hop, 2 hops, 3 hops, 4 hops. The answer is 4. So that is a distance of 4. And C to D, count your hops. 1, 2, 3, 4. So remember, count your hops, not your dots. Be the bunny. Be the bunny. So both of those were 4 hops. Okay, they're 4 hops. So what we just said was A to B is congruent to C to D. That's what we just said. So those are congruent. Okay, if A, B, and C are collinear, so meaning they're on the same line and B is between, so it's somewhere between it. There's no proof that it's smack dab in the center, so it's just off center. It could be over here, it could be over here. I don't know, but I know it's somewhere between. And what do? We do this plus this equals the whole shebang. So from A to B plus B to C is equal to the whole shebang A to C. So this plus this equals the whole shebang. And that should help you out. And I like using my arm. So I'll just use my finger for right now. But this plus this equals the whole shebang. This plus this equals the whole shebang. And that should help you out. Okay, so let's bust out some problems, shall we? Okay, so we know right here that E to G is 71. So from E to G is 71. Now there is no proof. There is no proof that F is in the middle. There's no proof that F is in the middle. We don't have any proof of that. So left does not equal right. We don't know that. But it could be, but we don't know. But we do know, in fact, that this plus this equals a whole shebang. So basically, we know that E to F plus F to G equals the whole shebang E to G. Or you could jump straight into the equation. 8x minus 17 plus 5x minus 3 is equal to the whole shebang 71. And now all we have to do is solve. Now, so remember, when you're on the same side of the equal sign, do the same operation. 8x and a 5x, they're both on the left side. So 8, 9, 10, 11, 12, 13. So it's 13x. A negative 17 and a negative 3 make a negative 20 equals 71. We're going to add 20 to both sides. We get 13x is equal to 91. 13x equals 91. Divide both sides by 13. I ran out of room, and I got x is equal to, and whatever 91 divided by 13 is, we get 7. Okay, so now, at this moment, we should have, what you want to do is you want to plug it back in. You want to plug it back into here. So plug back in. So plug it back in. So if I went E to F, so first of all, we know that x is 7. If we go to E to F, if we plug that back in, it would be 8 times 7 minus 17. And when you plug that in, you would get 39. So you get 39 when you plug that back in. So 39. If you plug F to G, so if you go 5 times 7, which is 35, minus 3, you get 32. And the whole shebang would still be 71. E to G is 71. Now, does this work? Does this plus this equal the whole shebang? Does 39 plus 32? When we add those together, we get 60, 71. Is the equation happy? Yes, it is. So I know that I'm happy with this. And what did they specifically want on this problem? They said, what is x? So I'm prepared to answer any question that they asked me. They could have easily have asked me any one of these, but in this particular case, all that they wanted was x. So that was the answer right there. So the answer was x equals 7, or just 7. All right, let's do another example. Number 2. All right, number 2, they said t to v. All right, so t to v is the whole shebang. So all from here to here is 14x minus 8. Now, this is not in the middle, so I know this plus this equals the whole shebang. So we have t to u plus u to v is equal to the whole shebang t to v. I'm just showing some extra work. So 9x plus 2 plus 5 is equal to the whole shebang 14x minus 8. And then you would just solve. Okay, I'm going to zoom in. All right, so we're just going to solve this problem here. Now, remember, when it's on the same side of the equal sign, do the same operation. 9x, there's only that one x there. Okay, 2x and a 5, sorry, 2 and a 5 make a 7 equals 14x minus 8. You want to get all the x's on one side, so I'm going to subtract 9x from both sides. Get 7 is equal to 5x minus 8. I'm going to add 8. 8, 9, 10, 11, 12, 13, 14, 15. I get 15 equals 5x. Divide both sides by 5. I ran out of room, so I'll put it up here. And I got x is equal to 3, or 3 equals x. Okay, and then you want to plug back in to be prepared to answer any question. So we want to plug that back in. So I want t to u, I want u to v, and I want the whole shebang t to v. So when you plug these back in, when you plug it back into the equation, is it happy? So 9 times 3 plus 2. So when you plug that back in, you get 29. Goes right there. And then this would still be 5. And then right here, 14 times 3 minus 8. When you plug that in, you would pop out with a 34. All right, and does that work? Does 29 plus 5 equal 34? Yes, it does. So I know I have all my right answers. And so we have every possible answer that they could ask for. What did they specifically ask for? So they asked for t to u, and t to u was 29, and that is your final answer. All right, so this plus this equals the whole shebang, and then you solve. All right, midpoint. Midpoint. Okay, the midpoint of a segment is a point that divides the segment into two congruent segments. Okay, so that means this side and this side are equal. A line or array or segment that intersects a segment at its midpoint is said to bisect. So break down that word. Bi, like bicycle, that means two, and sect mean you cut it into sections. So you bisect. So you bisected it into two sections. Okay, the segment is called the bisector. So this right here would be the thing that got cut. So the segment, and is called the bisector. Okay. Let me make sure I got that right. Read that right. Okay. So at its midpoint is said to bisect the segment, and it is called the bisector. Okay. So this is what is doing the action. So think the knife. So where's the knife? In this case, this is the knife. L is the knife. L is the bisector. L is the bisector. That's the knife. Okay, and in this case, because you see these notches right here? So those notches, that's telling me that this entire segment here is equal to that segment right here. So that means that this line and this line are equal. So AB is congruent to BC. Or equal. We can just say equals. Okay, so those two are equal to each other. All right. Okay, and then in the diagram to the left, B is the midpoint of A to C. And line L, and that's a cursive L, lowercase, is a line bisector. So it bisected the line. What got cut in half? The line of A to C. So is a line bisector of A to C. Okay, now the midpoint formula. I love the midpoint formula. It is awesome. The midpoint formula is so x mid is equal to, you add the x's together, so x point 1 and 2, add them together, divide by 2, and the y mid is equal to y1 plus y2 all over 2. So basically what I like to do is when you have points, so basically what you're doing is you're finding this distance right here, and you're finding this distance right here, and you're just dividing those 2 by 2, and that would be right here. That would be your midpoint right there. So that's what you're doing. So this is 0.1, this is 0.2, or vice versa. So you just add them together, divide by 2, and that will give you your middle. And me personally, I like to just stack the numbers one on top of the other. So I would just say x1 and y1, x2 and y2. You just stack them one on top of the other, x1 plus x2 all over 2, and y1 plus y2 all over 2, and then you would get your answer. And by doing this, you're going to save yourself so many mistakes because a lot of people accidentally add these two numbers instead of these two numbers. And we'll talk about that in a little bit. All right, let's go to page 8. Page 8. All right, man, I love this problem. I love these problems. These are great. Okay, so midpoint. Find the midpoint of G to H. So when you're looking for the midpoint, take the 2 points, 7 and negative 5. Stack them one on top of the other. Okay, stack them one on top of the other. All you have to do is add them together, divide by 2. Add them together, divide by 2. All right, 7 plus 9. So I'm going to go up here. So do the top all by itself. 16 over 2. So 16 over 2, and this will be negative 6 over 2. Divide by 2, you get 8 and negative 3. And that's your final answer. Right there. That right there is your final answer. Okay, so there's a couple of mistakes that can happen. A lot of people accidentally go 7 plus negative 5. That's wrong. Because that's your x and your y coordinate. You're supposed to only add your x's together. That's why we stack them one on top of the other. Another common mistake that people make is that in their calculator, they divide too early. So for instance, so a lot of people right here, 7 plus 9 divided by 2, you see how that says 11.5? We know for a fact it's really 8. What happened is we divided the 9 by 2, and then we added 7. So what you're really supposed to do is just do the top by itself. So 7 plus 9, parentheses, and then divide by 2. So hopefully you can see the difference. Hopefully you can see the difference. So you want to add them together, divide by 2. So make sure you do the top all by itself. Okay, so we're just catching all of our little mistakes. All right, over here, what's the value of e to k? So here's e, here's k, and I want to know that distance. And we talked about this before. I just want to know the midpoint, and actually in this case. So we know that this is 1, 2, 3, 4, 5, 6 hops, right? So we only want half of that. So we want to go 3 of those hops. So that's 1, 2, 3, and you landed right here at H, at 5. But instead of doing all that work, instead, you could have just gone 2 plus 8 divided by 2. That's 10 over 2, which gives us 5. So those are 2 different ways how to do this. Now you have to be careful. You have to be careful. Are they looking for H, or are they looking for 5? That's the question. Are they looking for H, or are they looking for 5? So they said name the value. So it just depends on your teacher. I'll let you know for definite, but name the value. So it could be H or 5. I will solidify that for you later. Okay. Okay, so if P is the midpoint. Okay, so now it's getting a little sketchy here. We're going to draw this. So P is the midpoint of X to Y. So we have X, we have Y. And P is smack dab in the middle. So that means that this side and this side are equal to each other. So the first thing we did was draw our picture, and now let's label. So notice I'm going to put anything that's these little parts on the top, and if it's the whole shebang, I put it on the bottom. And you just stay consistent. So x to p, that's a little part. So I'm going to put that on top. That's 8x minus 2. P to y, that's a little part. Let's put it on top. 12x minus 30. And that's all they gave to us. They did not give us a whole shebang. So I know two things. I know this plus this equals the whole shebang, but I don't have the whole shebang, so I can't use that. But I do know that the left side is equal to the right side. So let's do that. 8x minus 2 is equal to 12x minus 30. So the left is equal to the right, and we can solve. So I'm going to subtract 8x from both sides. And we get negative 2 is equal to 4x minus 30. Add 30. We get 28 is equal to 4x. Divide both sides by 4. And notice I always just show just a little extra work just in case anyone loses their spot. Okay, 28 divided by 4. We got 7 is equal to x, or x is equal to 7. Now, once you get the number, always plug it back in for two reasons. One, to catch your mistakes. But two, because sometimes they don't actually ask for x. Sometimes they ask for x to p, p to y, or x to y. So just get in the habit of always finding all of it. It's a good way to check yourself, and it's also to prepare yourself if they are trying to trick you and ask you for something else. All right, so x to p, if I plug it in here, 8 times 7 minus 2, that would be 54. 12 times 7, so 12 times 7, and then minus 30, I get 54, which works out because they're both supposed to be equal to each other, right? And what would be the whole shebang? So 54, p to y is 54, and the whole shebang would be 108, right? Because we'd add those two together. So x to y would be 108. So this is me just checking myself, and that does work. Now, what did they specifically want? They only wanted the x, so my answer is just 7. All right, almost done, guys. All right, so this one right here. So John started to grow his garden in his backyard. He decided to use the coordinate grid to show where strawberries are. He wants to put a sprinkler exactly halfway between. So here's the line, right? And we want to put it something exactly in between. So it's somewhere right here. So we want to find those two coordinates, add them together, divide by 2. So where are the coordinates? This is 2, 6. And this right here is 5, 1. Because remember, it's an xy coordinate. Along the x-axis was 5, and then I went up the y-axis at 1, right? So I stacked them one on top of the other. I'm going to add them together, divide by 2. So 2 plus 5 divide by 2, and 6 plus 1 divide by 2, which gives us, just add the top by itself. That'd be 7 over 2 and 7 over 2. And divide that. So it would either be 7 over 2, 7 over 2, or we can go 3.5, 3.5. Both answers are correct. So one or the other. Both are correct answers. So this one or this one are both correct. All right, 7. Find the coordinates of A. If M is the midpoint, so the midpoint is this. And of A to B, and B has this. Okay, so this one, this is actually really, really easy here. So basically, I know we have A and the midpoint and B. So make sure you guys are taking notes on this. This is a really good one. Leave some space. So I know M is -1, 2, and I know that B is 3, -5. So you just need to decide how you got from one place to the other. So I'm trying to go towards A. So how do you get from -5 to 2? I would have had to add 7 into my calculator for that to work. So -5 if I add 7, I would have gotten to 2. So you just keep trying numbers. -5, a lot of people are like, oh, +3? Wait, that got me -2. I need +2. So -5 plus 7, I get 2. Okay, just do that pattern again. Add 7. Where would you land? So add 7 again, we get 9. All right, let's do it again. 3. What do we have to do? Do we have to add or subtract? 3, we would subtract by 4. Just do that pattern again. Subtract by 4 again, and you would have -5. And that would be the coordinate. So -5, 9 would be my answer. All right, last problem, guys. Okay, on a coordinate grid, J to L is the endpoint, and endpoint L at -8, 6, and the midpoint is K at here. Okay, so we have K is in the middle, which is at -5, 10, and J to L is between the two. All right, so we could have gone J to L or L and J. It didn't matter the order. Okay, so in this case, we would have, just to show you how that it doesn't always have to be going up. I'm going to do L down here, J down here. All right, so let L right here be -8, 6. Okay, so in this case, how do I get from -8 to -5? What would you have to done? So just try out numbers. So you find it -8. I'm going to add 3, and I got -5. So I would have to have added 3. Just do that pattern again, add 3 again, and you have had 2. And it would be -2. All right, from here, we would have 6 to 10. We would have to add 4 again, and you get 14. And that's my answer. So -4. Sorry, 2. We got -2, 14. And that's your final answer right there. And how can you double check that? Another thing you can do is double check. Take the two outside numbers. So -8 plus that -2 divided by 2. We would have gotten -5 in the middle. That only works if you can see what I'm doing. All right, add those two together. Divide by 2, you would have gotten -5. 6 plus that 14 divided by 2, you would have gotten a +10. So that would have checked out. So that is the final answer. I hope that helped you guys out. Other than that, have a great and wonderful weekend.